Hello, this is Mr. Wynn, and today's video will be about rational exponents. So when you have a fraction exponent, you can change them into radicals with the root sign according to this formula. A to the m over n power, so that m over n is a fraction. That's called exponential form because it's an exponent. Turns into the nth root of a to the m power, which is radical form because there's a root sign. So for example, if I want to switch 4 to the 1/2 power, that turns into, well, the top of the fraction stays with the term, the number, and the bottom of the fraction, the denominator, is the root outside. So if there's a 1, we don't really write that, but I can check this. 4 to the 1/2 power should be the same as the square root of 4 to the 1st power. Well, 4 to the 1/2 power is 2, and y'all know the square root of 2, or 4 is 2. Alright, this next one, 4 to 3/2 power, well, 3 stays with it, is the exponent, but the denominator is the root outside. So, 4 to the 3/2 power gives you that, 8. And if I do the square roots, and I'll do like this, math 5, the square roots of 4 to the 3rd power, I also get 8. So you see where it's the same thing, we're just rewriting it different forms. One's in exponential form with an exponent, one's in radical form with the radical. So this last one, if I rewrite that, well, that 4 stays with the 3, and that bottom number is the root. So the cube root of 3 to the 4th power is the same thing as 3 to the 4/3 power. So here's some examples. Rewrite x to the 5/6 in radical form. Well, it's exponential form. I can change a fraction exponent into a radical, a root form. So the top, the numerator, the 5 stays with the x. That 6, though, is the root. So that's the same thing. B, write the 4th root of z in exponential form. Well, roots are just fraction exponents. So we know there's a 1 right there if you want that. So it's going to be z to the 1/4 power. And that's it. So make sure you know that roots really are just fraction exponents, and vice versa. Fraction exponents are roots, or can be written as roots. Alright, now all the exponent rules we learned before still apply. So now I'm going to use everything we did. First, remember, you cannot have a negative exponent. If you have a negative exponent, you got to bring it around, bring the whole term down, make it positive. So that's really 1 over 81 to the 1/4 power. Now, 81 to the 1/4, let me rewrite that as 81, the 4th root of that. And there's the 1st power if you want, but we don't need it. Now, the 4th root of 81, hopefully you all remembered, so I'll move this aside. We break it down the tree branch. So I'm using no calculator here. That's 9 times 9. 9s are not prime, so I break those down to 3 times 3. Those are prime. Those are prime. I'm finding groups of 4. So here's 4 of a kind. 1 goes out. The rest disappear. There's nothing left over. The 4th root of 81 is 3. So I'm going to replace the 4th root of 81 3 is 1/3. That's my answer. So just to make sure, the 4th root, math 5, I'm going to do the 4th root of 81, which is 3. If I try this, 81 to the negative 1/4 power, we don't like negative exponents, but you can put in the calculator, gives us 0.3 repeating, which as a fraction is 1/3. So I switch to negative sign by flipping it over the fraction, and then just change from exponential form to radical form, and we now take care of radical form, turn the 4th root of 81 to 3, replace it, and we're done. This one, fraction exponents are still exponents. If you're multiplying two things of the same base, you add the exponent. So for example, if I had x squared times x to the 4th, you should tell us x is 6, because that's 2x's here, times 4x's here, which is a total of 6x's. Well, in this case, it's the same idea, but we're not having whole numbers, we're having fractions. So if it's a to the 2 sevenths times a to the 4 sevenths, that's really a to the 2 over 7 plus 4 over 7. Sometimes you have to change to common denominator, but they're already good, so it's going to be a to the 6 over 7. And that's it. Example 4, simplify this. Well, I'm going to use a couple rules here. First, let's not use that form. Let's use exponential form. So that's really 27 to the 1/4 power over 3 to the 1/2 power. Because remember, if it's invisible, it's a square root. We need common terms. So here I did the product rule. When you're multiplying common bases, you add the exponents. Here I'm going to try to do the quotient rule. When you're dividing same bases, for example, x to the 7th divided by x to the 4, you subtract them. That's really 7 minus 4, which is x to the 3rd. Right. Now, 27 and 3 are not the same. However, we can replace 27 with another 27 that looks like common form. 27, y'all should know, is the same as 3 to the 3rd power. That is a perfect cube, because 3 times 3 is 9, times 3 is 27. All right. Now, I'm almost at common bases. The top gives us power to a power, an exponent outside of parentheses. So that's, you multiply that, so that's going to be 3 to the 3 over 4 divided by 3 to the 1/2. Now, since we have common bases, instead of x to the 3's, I can just subtract the exponents. 3 to the 3/4 minus 1/2. Well, I got to fix 1/2. 1/2, hopefully y'all know how to switch that, is really 2/4. Because 2 divided by 4 is the same thing as 1 over 2. And when I subtract, I get 3 to the 1/4. That is my answer in exponential form. If you don't like that, if you want to use the other form, you can say that's the 4th root of 3. That or that. All right, and again, I'll check using the calculator, show you that they're exactly the same. So I'm going to do a fraction. I'm going to do the 4th root. So 5, put a 4 out here. The 4th root of 27 divided by the square root. Second, that square root of 3 gives me this decimal. Well, that decimal should be exactly the same as the 4th root of 3, which it is. All right, so make sure you know your property rules, your exponent rules. All right, and the last one is this. Well, we've technically done this before. You know the old way, so let me do the old way first. We're going to break this down, find groups of 3. So that's 8 times 8. Those are not prime, so it's 4 times 2, 4 times 2, 2 times 2, and 2 times 2. All right. So here's a group of 3. Here's a group of 3. For each group, only one of them makes it out. The rest of the group disappear. The other group, one makes it out. The rest disappear. So there's no number that stays inside. So that inside's empty. Now for the z's. There are 6 z's. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. I'm finding groups of 3 again. So here's a group of 3. Here's a group of 3 for the row. There's going to be no one inside. For the first group, 1 z makes it out. The other 2 disappear. For the other group, another z makes it out. The rest disappear. So my answer here is 4z squared. That was the old way, which still works. Let me show you the new way. So keep in mind, we have our answer right there. The new way is, let's change this into exponential form. That's really 64z6 all to the 1/3 power. All right, remember, this is basically the term inside. The exponent here is 1, and the root is 3. So it's 64z to the 6 to the 1 over 3 power. Well, here's power to the power, exponent rules. I can distribute this everything inside to the exponents only. So here's the 1. So that's really 64 to the 1/3 power times z. Well, 6 times 1/3 is 6/3. All right. Well, 64 to the 1/3 power. Let me do this. The 1/3 power is really the cube root of 64. Hopefully I know that's a perfect cube, because that's just 4. Because 4 times 4 times 4 is 64. Or if you don't like that, let me replace 64 with 4 cubed. All right. So I replace that. And z to 6 over 3 is this z2. When you multiply power here, 1/3 times 3 is just 1. So it's 4z squared. Same answer, and it's technically a little bit faster than the other way. All right, here's the practice problem. Just write that in radical form. There's the answer. If you can do that, it should be fine for class. Again, this is Mr. Wynn. Thanks for watching. See you in class. Bye.